we can make a blanket statement that would say SN1 is faster than SN2, but there's all kinds of different factors that can lead to one reaction occurring more rapidly than another. Okay, so the three that we'd like you to be aware of would be the effect of the mechanism, the influence of the leaving group, and the choice of solvent. So what effect of the mechanism looks at really is basically, do you have a tertiary, secondary, or primary carbon? Tertiary carbon, so a tertiary alkyl halide, will favor the SN1 mechanism, while a primary carbon will favor the SN2 mechanism. Alright, this essentially means that if you have a tertiary carbon, the reaction should proceed faster than if it was everything else was equal and you had a primary carbon. Alright, there's some other important things to remember with this. An SN2 mechanism, while I didn't stress this in the SN2 video, leads to what's known as stereochemical inversion. So if you have a chiral carbon present in your alkyl halide, and you have one enantiomer, the other enantiomer is formed due to what's known as backside attack, because the incoming nucleophile has to attack from the opposite side where there is enough space. This leads to an inversion of stereochemistry. All right, so the next thing up would be influence in the leaving group. All right, and we can look at two things when we compare halogens. So we'll compare the two extremes of halogens, fluorine to iodine. The carbon-fluorine bond is very polar, while the carbon-iodine bond is pretty much nonpolar. The difference, though, is that the carbon-fluorine bond is actually very strong, while carbon-iodine is much weaker. Right? Through experiment, we can show that the carbon-iodine bond reacts much faster than a carbon-fluorine bond. So we would actually say that really it's the bond strength argument that dominates. So when we talk about influence of the leaving group, essentially the lower in the halogen series we find our alkyl halide, the faster it should occur. So this would be for both SN1 and SN2 mechanisms. All right, and choice of solvent. So again, an SN1 mechanism will work best if it's carried out in a polar protic solvent. So again, to produce, let's say, the fastest possible reaction, we would want to have a tertiary carbon where the halogen is iodine and it is carried out in a very polar solvent such as water. Right? To achieve the highest rate, out of an SN2 mechanism, so where the alkyl halide is found on a primary carbon, we would want to use a polar aprotic solvent, something like acetone or dichloromethane.